Ah, yes, implicit differentiation. So when you take the derivative using implicit differentiation, what you do is, since it's dy dx, you're taking the derivative with respect to x. Okay, so anytime you take anything that has an x attached to it, you just take the derivative. Anytime you take the derivative with something that's not an x attached to it, you take the derivative but attach dy dx to it. Okay, so find dy dx using implicit differentiation. I'm going to take the ddx of both sides, so 3x squared plus 3y squared equals the ddx of 2. The derivative of 3x squared with respect to x is going to be regular 6x, the regular old derivative just like we're used to. However, the derivative of 3y squared is similar, 6y, but since we're taking the derivative of y with respect to x, we attach dy dx. That's going to equal the derivative of a constant, which is 2. 0. I meant to say 0. Let the record reflect. I meant to say 0. Now what I have to do is I have to get dy dx all by itself. Well, dy dx isn't all by itself. I have 6y attached and 6x floating. So let's subtract 6x from both sides. That gives me 6y dy dx equals negative 6x. Dy dx still isn't all by itself. I have to divide both sides by 6y, do the same thing here, divide both sides by 6y, cross u out, and I'll put over here my final answer, that dy dx, which is all by itself, equals negative 6 over 6, which cancels out, x over y, which is x over y. And that's my answer.